Good afternoon, everyone. I hope you all will agree to make any metro project financially viable or sustainable, its operation and maintenance cost has to be minimized. So, the primary object and the energy consumption cost is around 35 to 40% of any typical metro project of its total O&M cost. So, to minimize the operation and maintenance cost, the energy consumption cost has to be minimized. So, while designing a traction and power system of any metro project, the primary objective of the designer is to keep the energy consumption levels low. In Kanpur metro projects, we have taken various energy efficient technologies like 100% LED lighting system, energy efficient pumps, air conditioning, regenerative braking in lifts, regenerative braking in rolling stock, to name a few. Kanpur Metro Rail project is based on 750 volt DC third rail traction system. These are the two new things which we are using in India, which is the first time in any metro project. The first one is we are using inverter technology, which is also called as reversible traction substation, to recuperate the energy produced by rolling stock while braking. And the other one is automatic short circuiting earthing device, which we'll discuss in detail how it will save the manpower and the maintenance time, and which translate ultimately into reduction in man hours and O&M cost. With the help of advent of technologies in variable voltage, variable frequency drives and induction motor, now the present day rolling stock is having this feature of providing regenerative energy while braking. So in DC traction system, in DC rolling stock, the most common way of doing it is having an on-board brake resistor system, which is installed inside the train. When the rolling stock is braking, the regenerative power is being generated. To keep the voltage within the limits, this energy is being wasted in the on-board brake resistors. So it is a highly inefficient way of utilizing the energy, because you are wasting the energy in the form of heat. And to worsen it, if you are using the same inside a underground tunneling system, this heat is compensated by the air conditioning of the underground system. Also, the train need to carry the dead weight of onboard brake resistor all the time, which again increases the specific energy consumption of the train. So there are various methodologies available to recuperate this energy instead of wasting it in the brake resistor. The one is using a wayside energy storage devices. Another way is having a onboard energy storage system. And the latest, or I would say the latest available technology, is using a reversible substation or using an inverter. In wayside energy storage system, this is using lithium-ion and nickel metal halide batteries, along with sometimes supercapacitors also for storage of regenerative energy. So when the train is braking, the energy is being fed from the rolling stock to the nearest substation where this energy storage system is installed. And whenever the train is accelerating or demanding power, this energy system will feed it from the substation to the rolling stock. So each time the energy has to travel from train to energy storage system and back to train whenever it is required. So the line transmission losses are a bit higher in this case, so which can be further minimized by positioning the location of the energy storage system, for which various simulation tools are available. One more benefit of having wayside energy storage system is this ability to minimize the problems related to voltage sag. When the train is demanding power, at that time voltage is supposed to be lower. So at that time this energy system can compensate and reduce the voltage sag. Another way of doing the same is using the same technology, using same supercapacitors, lithium-ion batteries or nickel metal halide batteries, put this whole energy storage system inside the train. So the line losses will not be there. But the disadvantage in this case will be the train has to we have to make the space inside the train, and again the train has to carry the full weight of the energy storage system all the time. So we have another system which is called as reversible substation with inverter. In this, an inverter is connected in anti-parallel with the rectifier to allow the reverse power flow in the DC traction system. That means the power will flow when the train is braking. The regenerative power will flow from the DC traction system, and here it will be again converted through this inverter into AC, and through some mechanism, maybe through transformer or auto transformer, this will be fed to the secondary of the main transformer, and it will fed to the medium voltage grid. When the energy is fed back to the medium voltage grid, it can be utilized anywhere in the grid. Maybe in the auxiliary system, maybe in other trains which are far away from the generating train. So this is the beauty of this reversible substation. This is a typical schematic of inverter system. We are having a DC switchgear, DC high-speed circuit breaker. Then in inverter cubicle we are having IGBT diodes and some reactors to maintain the quality of the power. Then we can have auto transformer or transformer. In Kanpur Metro we are using auto transformer technology along with inverter to feed back the exact voltage which is required to the secondary of the traction transformer. We have done a cost benefit analysis for corridor 1 of Kanpur Metro. As per the headway in the DPR, considering 16 hours operation in a day, we could save an energy of around 7,500 units in a day, which translates into 2.2 crores rupees of saving in a year. Considering a cost of transformer 2.5 crores as of now, if we are putting 3 transformers in the corridor, the payback period is less than 3.5 years. So to summarize it, this is the first time in India we are using inverter technology. We are using an IGBT inverter, 1 megawatt IGBT inverter with auto transformer. By using this inverter, we could see that the energy consumption through the grid will be reduced. We have proposed 3 inverters in corridor 1 and 1 inverter in corridor 2, since the length of the corridor is a bit less and payback period is less than 4 years. Another new thing which we have used in Kanpur Metro is, let's talk about in DC traction system, or for that matter in AC also. Whenever we take a power block for maintenance, we have to use the discharge rods to make sure that there will not be any residual voltage or any residual current, or in case of during maintenance there should not be any power flow. In DC traction system we are using portable short circuiting devices. It's a similar form to like we use in AC traction system. In this we just short both the running rails and to the third rail to avoid to discharge all the residual voltage. This discharge rod is a bulky device, around 25 kg or so, and this has to be carried out by the maintenance staff. And since it is a manual process, so there is always a safety hazard. The staff may get electrocuted in case of any not taking proper precautions. And and in this case the maintenance time is also high. And if during the breakdown, this can directly translate to the can directly affect the revenue operation. In Kanpur Metro, instead of using this portable short circuiting device, we are using automatic short circuiting earthing device. This is again we are using first time in India. These devices are panel based, and these can be housed in the traction substation, and the running rail and third rail is connected through cables to these panels. These are the motorized one. It can be remotely operated through SCADA. In portable earthing device, earthing is also not foreseen. In short circuiting earthing device, we can do earthing also of the system. So the time reduction, it significantly reduces the maintenance time. To make it more, you can appreciate it more, if I'll quickly briefly touch this upon. Whenever we are using a portable SCD for maintenance, The process is the staff has to take the permit to work. After taking permit to work, he has to check where the portable SCD is kept. Then they have to carry this portable SCD all the way along with all the tools, spares to the site where the maintenance is to be done, which is typically around 500 to 600 meters from the station. So they have to carry along. Then there they need to check whether that all the third rail or running rail is off or not through some voltage detector also. Then after that only they can start the maintenance. In case of automatic short circuit and earthing device, they just need to obtain the permit to work, tell the SCADA operator to do some few clicks, and after the few clicks, they are ready to do the maintenance. There are two types of short circuiting devices are available. One is 4-pole, in which you can use, you can connect the both upline and downline along with third rail. And there is another way of having 2-pole short circuiting device, in which one side of the rail, that means upline or downline, can be connected to the third rail. We are using both of them. In depots we are using 2-pole, and in main line we are using 4-pole isolators. So thank you for patiently listening to me.